Good afternoon, and thank you for joining us to celebrate the handover of NASA's Airspace Technology Demonstration 2 to the FAA for implementation across the United States. I'm NASA Press Secretary Jackie McGinnis, and in the first part of today's event, we'll hear from leaders from NASA, the FAA, and Charlotte and Dallas-Fort Worth airports about the impressive benefits of the ATD-2 technology before opening it up to answer your questions. We have with us today NASA Administrator Bill Nelson, a longtime supporter of the aviation industry. During his time in the Senate, Nelson was the ranking member of the Commerce, Science, and Transportation Committee and served on its Aviation, Operations, Safety, and Innovation Subcommittee. FAA Administrator Steve Dixon oversees the agency's mission of achieving safety and operational excellence in the skies above the United States. He previously had a long career with Delta Airlines, serving as their Senior Vice President of Flight Operations. We're also joined by Aviation Director of the Charlotte Douglas International Airport, Haley Gentry, who manages the airport's operations, business portfolio, IT, and economic and community affairs. And finally, Chris Mclaughlin, Executive Vice President for Dallas-Fort Worth International Airport, where he manages the vision, direction, and strategy for its physical operations, including safety, airside operations, sustainability, and integrated operations. So first, Senator Nelson, I'd like to hand it over to you for opening remarks.
Hi, everybody. For decades, NASA has made aviation more sustainable and dependable. And it's in our DNA. And remember, the first A in NASA is aeronautics. Earlier this month, I joined the Biden administration officials to discuss sustainable aviation. And we highlighted how NASA is working hard on combating climate change. And that includes this partnership with the FAA and industry. And so today we're going to celebrate the transfer of the integrated arrival, departure, and surface management technologies that was developed and tested through NASA's Airspace Technology Demonstration Project. Now, where did this come from? It came from the strategy of figuring out for space the trajectories to get where you wanted out in space to other planets. And the idea behind this was simple. Take that technology and apply it to an aircraft when they are pushing back from the gate, taxiing to the runway, take off, and reaching cruising altitude without stopping. We had already done this with the FAA years ago on descent. You think when you're cruising along, say coming from the south into DCA, you start descending about over Richmond, and it is continuous. It's not a stair step. Go here and then go down another level and go down. It's a continuous, and it's saving fuel. And NASA and the Federal Aviation Administration and American Airlines started testing this software now for departures instead of arrivals. And today, we know this works. And what does it do for us? Safety, efficiency, dependability, and the proof's in the pudding. For example, at just one airport and for just one airline, this technology helps save over 1 million gallons of fuel over a 2-year period. Now that means that's money saved by the airlines. That means it's reduced CO2 emissions. As a matter of fact, in that 1 million gallons, 23 million pounds of CO2 emissions. And that's equivalent to planting more than 170,000 trees. Well, let's think of some of the other things. If you can push back from the gate and you don't have to sit out on the tarmac, well, you're going to not sit on the taxiway. You're going to push back and you're going to go straight to the end of the runway, and you are going to take off, and you're not going to stair step up. You're going to constantly go up to your flight elevation. What have you done? You've saved time. You've saved the time of use of the aircraft, of the flight crew. By the way, have any of you ever missed a connection? Or did you get to your destination and you made the connection, but your bags didn't make the connection? All of this is planned in advance. And this technology cut delays by all kinds of hours, and the aircraft engines run all kinds of fewer hours. And what does that mean? That means less maintenance and fewer replacement engines. This is obviously good for our environment. It's good for our economy. It's good for our passengers. It provides shorter, more comfortable flights. And this demonstration provided that passengers had an estimated $4.4 million of value added to their time. Bottom line, this is the power of public-private partnerships. In 2021, this partnership expanded to involve American, again at Dallas-Fort Worth, and also Southwest at Dallas Love Field. And that's not all. This demonstration advances an already strong partnership between NASA and the FAA, as I've already indicated on the ascent. In 2015, NASA transferred technologies to enable fuel and emissions efficient descents into airports, which had the potential cost savings of $500 million per year in fuel costs. And when most Americans think about NASA, they think about space. But this demonstration, as I said, builds on the existing expertise and technologies developed in our space trajectories. And this is applied to the commercial aviation sector. NASA Aeronautics contributions are proof that NASA technology has the power to both explore the heavens and also improve life here on Earth. This demonstration is more than a success story. It is a story in the making. Imagine the possibilities when the FAA deploys NASA technology at airports across the country. Through this demonstration, NASA once again proves its value to our nation, building on decades-long problem solving of the nation's toughest challenges. This can-do agency will continue to make history in air travel for generations to come. And now I want to turn it over to our partner. This is the FAA, and introduce you to our FAA Administrator, Steve Dixon.
Well, thank you, Senator Nelson. And you said it so well, and I'm, first of all, very pleased to be here with all of you. And as Senator Nelson said, aviation and space, for that matter, are really a team sport. And we are so fortunate that NASA's on our team. We're better for it. We're safer for it. We're more efficient, and we're greener. And so, Senator Nelson, I am so grateful for your leadership, your partnership, and the FAA's partnership with NASA. And that's why we're here today. We're here to show how our collaboration in using technology and data, and also working with airports and airlines, has led to a promising technology that's going to result in a more sustainable aviation system, a safer system, a more reliable, a more predictable system, and a better passenger experience overall. The climate crisis isn't something that we can just leave to the next generation. We know that. My wife and I just welcomed our fourth grandchild here a few weeks ago. And so this is something that's very much top of mind for us. The capability that we have been testing for the last few years, and that the FAA will deploy across more airports as part of a larger surface traffic management system, shows that we aren't standing by. This capability reduces aircraft fuel burn and carbon dioxide emissions, and it shaves many minutes of time off of each flight, potentially, once it's fully implemented. The software calculates when it's best to have the airplane push back from the gate at busy hub airports so that the airplanes can roll right to the runway. With this capability, we can reduce taxi delays and ramp congestion. And after takeoff, the system enables air traffic controllers to merge your flight right into the stream of jet traffic. The flight crew loves it, passengers love it, and we're documenting great results. For instance, at Charlotte Douglas International Airport, the system generated enough fuel savings each year for 185 flights between New York and Chicago by a Boeing 737. Very impressive. The system also shaved 15 minutes of waiting time on the ramp or taxiway for more than 3,600 departing flights. Now, as part of the FAA's Terminal Flight Data Manager system, we will deploy this new surface management capability at 27 hub airports across the United States. And if you do the math, the numbers get very big, very fast, and in a good way. Across these 27 airports, we estimate a savings of more than 7 million gallons of fuel and the elimination of more than 75,000 tons of CO2 emissions every year. Now, the research and testing of this technology shows how we can use advanced data analytics to make flying more efficient, more sustainable, and safer. These kinds of data analytic technologies can put us in a position to make countless other improvements in aviation and offer greater value for the American public that we serve. Again, I want to thank NASA for partnering with us to develop, demonstrate, and now deploy this technology in our operational systems. Members of the airport and airline community were also great team members in this effort, and you'll be hearing from several of them today as well. It's been a tremendous collaboration. Next, we're going to see a brief animation video that illustrates the capability a little bit, and after that, we'll hear from the airports who have been partners in this work. Thank you.
One of the biggest opportunities our country has to tackle climate change is making transportation, especially aviation, more sustainable. The FAA and NASA have been working to solve this problem with a new system that reduces delays for the flying public, which means less fuel use and lower carbon emissions. Until recently, we didn't have predictable aircraft movement times. Traffic managers had to build in bigger buffers, which led to delays on the taxiways and runways, and increased fuel consumption and emissions. Now, with this new software, the FAA's Air Traffic Organization, airlines, and airport ground operations can determine the best time for a plane to push back from the gate and roll essentially non-stop to the runway, then take off in a perfectly choreographed sequence. As planes depart, they join high altitude en route traffic with greater efficiency and less airspace restrictions. The benefits include millions of gallons of fuel savings, reduced flight time, including waiting time on taxiways, and the elimination of more than 75,000 tons of CO2 emissions every year. The FAA will deploy this new surface management concept at 27 hub airports across the country. The FAA, partnering with NASA, is committed to reducing carbon emissions for aviation. Flying needs to be more sustainable, and this technology helps us get there.
Thank you, Administrator Dixon, and thank you to everyone for inviting us to participate today. On behalf of everyone at Charlotte, I would like to thank NASA, the FAA, and American Airlines for choosing Charlotte as a location to conduct this important study. When most people think of airports, they think of aircraft arrivals and departures, parking, security checkpoints, and trying to make their flight on time. All of that is extremely important to our operations and certainly to our customers who are seeking to reach their final destinations as quickly as possible. But for those of us in the business of airports, we know there's so much more to it. When the opportunity came to participate in this test program, knowing the innovation and positive changes this could result in, we jumped at the chance. And that was in 2016. Charlotte, American Airlines, NASA, and the FAA agreed to participate in a test program to look at the enhancement of aircraft movement, both on the surface and in the air, to increase operational predictability for aircraft while reducing emissions, fuel burn, and delays. At the beginning, we supported NASA by creating maps of our airfield, providing physical space for them to put a lab on site, and additional various operational support as needed. Our unique geographic location, along with our position as American Airlines' second largest hub, proved to be beneficial. We had a lot of inventory here. We have a lot of airplanes on the ground and operating on our airfield. This was exactly what was needed to conduct a technology test that would manage the aircraft on the ground for a much more efficient utilization of our airfield. The data really speaks to the success. As Senator Nelson shared with you, we've been able to reduce taxi times. We've been able to produce less emissions, which has resulted in 1 million gallons of fuel savings. Also, reducing greenhouse gas emissions by 8 tons of CO2 on a daily basis since the testing began in September of 2017. For our customers, this technology has helped make departures more predictable. Boarding times, pushback, and taxiing to the runway are calibrated for an exact takeoff time to fill the gap into the highway in the sky. This partnership has proven to be a positive experience for our passengers, sustainability efforts, and the overall business of Charlotte. I'd like to thank NASA, American Airlines, the FAA, and everyone who's made this opportunity possible. We are excited for the future of this technology as we move forward. Now I'd like to introduce Chris Mclaughlin, Executive Vice President of Operations at Dallas-Fort Worth International Airport.
Thank you, Haley, and thanks everyone for having us today. It's really an honor to be here. DFW is incredibly proud to have participated in the North Texas ATD-2 pilot that allowed the FAA to identify measures to optimize our arrivals and our departures. Utilizing new methods and tools to deconflict two major US airports and their partner airline operations is a significant accomplishment. And that's really what we brought to this aspect of the test is think about it, two airports within very close proximity to each other with two of the largest airlines in the US and the world operating together. So bringing NASA, the FAA, airports, and airlines together to solve complex airspace challenges in a collaborative environment has really become a blueprint for future success. The outcomes of this demonstration project provide better capabilities for air traffic control to dynamically reroute aircraft safely around weather cells, making the biggest difference on our toughest days. In addition, improving airspace navigational procedures during inclement weather reduces delays on the surface, making our passengers much more happy. We see ATD-2 as a firm step forward, a more integrated and technologically advanced national airspace system to which DFW is committed. Over the past 2 decades, DFW's sustainability mission has leveraged efficiency investments to drive improvements in our carbon footprint while reducing costs at the same time. The ATD-2 project incorporates digital tools to enhance decision-making during disruptive weather events, which results in reduced fuel consumption, reduced emissions, reduced costs, and ultimately reduced surface delays. Again, in the end, our passengers and our airline partners are the biggest beneficiaries. And as a result, we are excited to see this critical investment move forward to full-scale implementation. Thank you again for your time today. And with that, it's my pleasure to reintroduce Jackie McGinnis.
Thank you, Chris. We'd now like to open it up for your questions for this first group of participants. I should note that Administrators Nelson and Dixon will have to leave after this segment. But in order to ask your questions, please use the raise hand button at the bottom of your screen and remember to unmute yourself. First up, we have a question from Alan Levin with Bloomberg News.
Hi, and thank you very much. Can you hear me okay?
We can, thank you. Okay,
great. This question, I guess, is for Administrator Dixon or somebody at FAA. What are the implications of this system on the way delays are recorded? So, for example, there's an incentive for an airline to push back so they don't take a delay at the gate, but in some cases it may be a lot more efficient to have them wait another 5 minutes at the gate, et cetera. And then is this counted as an air traffic delay or as a delay by the carrier in terms of what DOT is looking at? And thanks very much.
Well, Alan, that's a good question. I think that we will not change. There aren't any plans to currently change where the movement area and the non-movement area are at the airport. So in other words, the ramp area where the airline is operating or the airport is controlling versus what the FAA is controlling through our air traffic organization. But what it does do is it closes that seam. And so what you'll hear later in the program, one of the things that the airlines are doing is providing 11 data elements to the FAA so that we can use this and they can use it for improved decision support about whether to hold a flight for connecting passengers or bags, or whether they need to go ahead and push off the gate to be on time at the destination.
Thank you.
Thanks. And next we have a question from Micah Maidenberg with the Wall Street Journal. Micah, are you able to unmute? If not, we'll move on to Will Robinson Smith with Spectrum News.
All right, I think I'm unmuted. Can everyone hear me all right?
Yes, we can.
All righty, thank you so much for taking the time to answer our questions on this. I guess a dual question for Administrator Nelson and Administrator Dixon. The 27 airports for which this technology will be rolling out. How were those determined, and when will those airports be able to start tapping into this technology? And then for Administrator Nelson, as this starts to turn over to more of an FAA-driven initiative, what will NASA's role be moving forward in this? Thanks.
Well, I'll hit the airports and operational issue. Again, as with any technology transfer, we will integrate the system into our broader surface traffic management system that is being deployed out across the national airspace now and at our airports and control towers at the larger locations. The 27 airports were chosen because of traffic volumes and their role in connecting our national airspace system. We obviously have the airports that really perform very important connectivity purposes within our aviation system in the United States. And so the 27 airports were chosen because of the value that they provide. And we can get you more in a follow-up on that, more granularity on exactly what that decision-making process was.
And Will, your question about what is the future of NASA, first of all, this is part of what has generally been known as the next generation of air traffic control. And we will continue to work with the FAA as that whole system is perfected, which also includes the flight at elevation from destination A to destination B before the descent and after the ascent. But what is NASA doing for the future in aviation? My goodness, we have a lot of exciting things. We are building an electric airplane. We will be flying a test demonstration vehicle with electric engines. We are also building an airplane that looks out of this world, this needle-nosed creature coming out of the skunk works that will be able to fly supersonic over populated areas because we are lowering the sound of the sonic boom. And thus you can imagine to fly from point A to point B at half the time because of going several times Mach, and to do that to fly over populated areas. So there's an exciting future in our aviation research.
Thank you. And unfortunately, we only have time for one more question with this group. I'd like to open it up to Kyle Arnold with Dallas Morning News.
Sorry, I just unmuted myself. What's this going to look like to consumers? Is it going to look like departures are pushed back before they get on the plane? Is it are schedules going to be adjusted hours in advance? How will this kind of solve some of the problems that consumers have had with excessive cancellations and delays?
Well, Kyle, it's a great question. The goal here is to improve the reliability, on-time performance, fewer cancellations, and the predictability of the system. So as Senator Nelson said in his remarks, and as I reinforced, really it's about making the system more reliable and taking these delays that are happening currently on the ground with queues on the taxiway or in the ramp area, eliminating those bottlenecks. And so what happens here is that right now, and historically, the FAA doesn't have, our air traffic controllers don't have visibility into a flight. I mean, we have the airline schedule, but we don't know exactly, when they're going to be departing until they hit the spot on the ramp and talk to air traffic control. Now we'll have advanced visibility into the metrics that the airline has, so that we can be much more specific about predicting an on-time departure. And that just allows us to manage the rest of the system much more effectively and remove those bottlenecks on the ground. So what we should see over time at the larger airports are fewer delays on taxiways and better on-time performance.
Thank you, Administrator Dixon, and thank you to all of our participants in this first group. With that, I'd like to hand it over to Jeannie Schiffer with the FAA to introduce our second group.
Thank you so much, Jackie. And yes, we are moving on to our technical discussion, and we will start with Bob Pierce, who is NASA's Aeronautic Research Mission Directorate Associate Administrator, and then we will be followed by Pam Whitley, who is FAA's Assistant Administrator for Next Gen. Bob, go ahead, please.
Thank you. It's a real pleasure to be with you all today. And as Associate Administrator for Aeronautics Research, I can tell you that the work we do in partnership with the FAA to improve and transform our nation's air traffic management system is one of the key cornerstones of our research portfolio. Senator Nelson talked about some of our other cornerstones. I'll mention those briefly later, but this really is, this partnership has been, we've been working for decades with the FAA, and it's, this is a culmination of a lot of that work. I want to say that partnership we have with the FAA, of course, it extends beyond just NASA and FAA, extends to our airline partners, to airport partners, to manufacturers, and it really is incredibly productive. What you've heard already today is a testament to the productivity of that partnership. And so what you're seeing is here's a culmination of years of research that we've been doing to support the achievement of FAA's next gen air traffic management system. And of course, the goal here is for each aircraft to have the most efficient trajectory possible from gate to gate. And that's in the presence of a lot of constraints. There are constraints, each aircraft has to stay, safely separated from other aircraft. There's weather in the system, wind, there's limited runways and gates and so forth. So all those constraints need to be taken into account as we make these complex trajectory calculations that then could be executed by the airlines and by the FAA, and that's all embedded in the software that's been talked about here. So it's a lot of work goes into developing those algorithms, obviously testing them out in the laboratory, and then what we did with Charlotte and with Dallas Fort Worth is those flight trials that prove the benefit of these systems so that they are ready for general application in the throughout the system. So in just a couple of minutes, you're going to hear from some of the key folks across NASA, FAA, airlines, airports, and so forth. They've been working on this technology, on the ATD technology now for years. And in addition, they've been with us as we worked on the descent tools that Senator Nelson talked about, as well as the en route weather avoidance tools that we've been working on as well. So these folks and others have been partners with us for many years. And they'll be partners as we extend these efforts towards the future, as we look at how do we, now that we've done each of these components, the departure, taxiway departure and takeoff into the en route stream, the en route flight, the weather avoidance and so forth, and then descent and arrival operations. Now we want to look at how we optimize across that entire trajectory, and so that'll be one of the next things we do. But in addition, as Senator Nelson said, we're working on a number of in other parts of our research portfolio, looking at supersonics, looking at how we support the eVTOL industry, looking at small drones, looking at high altitude long endurance aircraft and so forth. So all of these components also have to be supported by the air traffic management system. So we're also looking at how do we extend these tools and new tools to accommodate these new kinds of aircraft as well. And of course, we'll be working just as we do today in close partnership with the FAA to make all that happen. So this is a big day for us, this culmination of this work on ATD-2 And it is, is one of a series of things that we have done over the years. And so while we celebrate today, we look forward to tomorrow in the future where we do more of these. And before we get to the panel, though, I'd like to introduce, my colleague at the FAA, Pam Whitley. She's the FAA Assistant Administrator for NextGen. And over to you, Pam.
Thank you, Bob, and good afternoon, everyone. I echo some of the comments that you've heard earlier. We're here today really to talk about the transition of technology from the FAA, from NASA to the FAA. But the theme here is collaboration and partnerships. So to make something like this happen, we've had years of partnership between the FAA and NASA, our airline partners, our airport partners, our unions, and many subject matter experts, some of which you'll hear from on the panel coming up. So what happens when technology is transitioned from NASA to the FAA? It means that the research work has been completed. We've demonstrated that the capability is beneficial, and we will move out at the FAA and build an acquisition program based on what we've learned. So this work will go into a program that we've already started, which is the Terminal Flight Data Manager program, which we call TFDM. And this system is designed to support surface management. And what we will get out of this system is a modernization of the air traffic control tower equipment, streamlining capabilities to streamline the flow between arrival and departure aircraft. We'll see fuel savings and reduced emissions, and basically an optimization of the experience for the traveling public, which I think was explained very well in the video. So we are just excited to really talk about the fact that these partnerships have existed, and that we're in a phase of building blocks to get capabilities used in the national airspace system day to day. This is not the first technology that we've transferred, or the first transfer of concepts and capabilities from NASA to the FAA. However, it is a very important one in a series of things that we've already transitioned to support the improvement of surface management. I'd like to acknowledge both Charlotte and DFW, because they were all in, as we like to say. They have been our partners in the outset. They've worked with us to make sure we had the support that we needed from an airport standpoint, be it facilities, technologies, access to the airports. Our airline partners, we learned a lot from them in terms of what was important in terms of sharing of data and information. And, they not only were at the table, in many cases, they had to make investments in their own technology in order for this to work. So what you'll hear is that we have really taken information that existed in silos, and we're beginning to integrate that information so that we have the ability to create a common near real-time view of the surface environment or the terminal environment, to include aircraft arriving at the airport, aircraft that are on the surface, and aircraft that we're planning departures for. You will find that going forward, there are opportunities for us to do even more And we'll have a third phase of TFDM, which begins to integrate the weather information. So I just want to say thank you to everybody that's been a part of this. I do think we've had a great collection of experts at the table, and they've spent many hours working on technical details, and I'm sure they'll be able to share that with you. So, Bob, again, thank you for the partnership. It's been a long-lasting relationship, which will continue as we continue to modernize the national airspace system. So the future is bright. And you will see this in the NAS as the Terminal Flight Data Manager System real soon.
Thank you very much, Pam. And as Associate Administrator Pierce mentioned, there was a great team of people who made this technology transfer a reality. And we have some of them with us here today. So I'd like to introduce our technical panel next. We have Captain Robert Goldman of Delta Airlines. He is also chair of the FAA's Next Gen Advisory Committee's Integration Working Group. We have David Seymour, Chief Operating Officer of American Airlines. Rick Dalton, Director, Airspace and Air Traffic Management Network Operations for Southwest Airlines. We have Rich Santa, President of the National Air Traffic Controllers Association. And from NASA, we have Akbar Salton, Director, Airspace Operations and Safety Program, and Sean England, Airspace Technology Demonstration Project Manager. And from the FAA, we have Steve Bradford, who is the ATD-2 Program Lead, and Wendy O'Connor, Trajectory-Based Operations and Northeast Corridor Group Manager for the Air Traffic Organization. So let me turn it over to Captain Goldman.
Hello, and thank you. It's my privilege to be sharing the virtual stage with so many prominent leaders and colleagues across our industry. On behalf of Delta Airlines, we're proud to have long partnered with NASA and the FAA and others, always looking for opportunities to innovate the travel ribbon, always striving for improved safety, efficiency, and sustainability for our customers and the global community. NASA's Advanced Technology Demonstration is just one example of such projects that Delta has been a strong partner with NASA and with our industry associates and the FAA. Of note is ATD-2, which today we recognize, the tech transfer from NASA to the FAA. Speaking as the industry co-lead of the Surface and Data Sharing Next Gen Implementation Work Group, which makes recommendations to the FAA through the Next Gen Advisory Committee, ATD-2 is one of those instances in life when you ask for one thing and you get so much more in return. Originally, it was a response to the industry's recommendation for a departure queue management demonstration. ATD-2 has provided our industry tremendous insight and experience into an integrated trajectory-based paradigm connecting surface operations to the en route environment. Integration in this context not only includes connecting ATC automation tools, but it also includes processes and people as well. People not only include pilots and controllers, but dispatchers, ATC coordinators, airport authorities, and many, many more. All this highlighting a holistic approach to efficiency defined by total throughput. And by the way, improved throughput also corresponds to reduced emissions. Also incredibly important throughout the ATD-2 project was a focus on data exchange as an enabler for this integration. This concentration opened up additional opportunities around better access to and understanding of the underlying data, leading to greater efforts in analytics, machine learning, and other related disciplines, many of which are still being worked in Swift and other forums. Also, along the lines of data exchange, we're extremely excited about Digital Information Platform, or DIP, which falls under NASA's new ATMX project. While not a direct continuation of ATD-2, this new project promises to build off lessons learned and continue the important work in this space with a wider focus on traditional and new entrant aviation integration, as well as broader use cases that support our industry. I want to close on the recognition that ATD-2 closely paralleled the development track of the FAA's Terminal Flight Data Manager program. TFDM is the FAA's surface decision support tool that's previously been mentioned. By running these programs simultaneously, it's opened greater opportunities to exploit expanded use of modern project management processes such as Agile. As we look to the future, we should continue to employ Agile development processes, thus allowing us to get programs developed and implemented in timeframes that keep them relevant to support the frontline workers and the traveling public. Before turning over to my colleague at American, I just wanted to again thank NASA and the FAA and my industry partners for the incredible work on ATD-2. I have had the pleasure to work with leaders, engineers, project managers, controllers, and everyone in between. And I'm impressed by everyone's commitment and collective brainpower. We look forward to the continued collaboration. With that, I now turn it over to Mr. David Seymour, Chief Operating Officer at American Airlines. Over to you, sir.
Thank you, Captain Goldman. I appreciate that. Hi, everyone. I'm David Seymour, Chief Operating Officer at American Airlines. And it's a pleasure to join you virtually today on behalf of the many American team members who have contributed in one way or another to the ATD-2 project over the years. We got in on the ground floor with ATD-2 and have been engaged with NASA and the FAA as the project took root at two of our major hubs, Charlotte International Airport and Dallas-Fort Worth International Airport. At American, we work every day to make sure we're building our airline to thrive forever. In that respect, reducing our impact on the environment is essential. And that's why it is important for us to be involved in demonstrating how the ATD-2 concepts work in our operation and working alongside NASA in analyzing their impact. Airlines face significant challenges when it comes to sustainability. At American, we're committed to meeting those challenges head on with ambitious goals and a plan to achieve them. An important component of that plan is making continuous operational improvements, both on the ground and in the air, to reduce our carbon emissions. We know reducing emissions from aircraft is as much a priority for our partners in the industry and in the government as it is for us. The fact that we share that goal is absolutely crucial for success. Decarbonizing aviation is no easy undertaking, and no one segment of the sector will be able to create our low carbon future on its own. Collaboration, like the collaboration we've demonstrated with ATD-2 project, is key. Most importantly, what we're demonstrating through ATD-2 is that even small changes in the way we operate can make meaningful differences in reducing emissions. Plus, our customers will no doubt appreciate fewer delays on taxi out and takeoff. It's a proof of concept that we're ready and eager to push forward both in our operation and across the industry. So from all of us at American, thanks to all the entities represented here who've applied significant amount of time and energy improving efficiency in aviation through the ATD-2 project. We're particularly grateful to NASA and the FAA for partnering with us and for including us in today's program, and we stand ready to continue that engagement in the future. With that, I'll turn it over to Rick Dalton with Southwest Airlines.
Thank you, David. And thank you to all of my fellow panelists and those joining this virtual conference today. And first, I offer my congratulations to the NASA IADS ATD-2 team for their award as runner-up at Software of the Year Award, and the FAA for their continued partnership in these efforts. As we look to the future of our air transportation system, we see tremendous promise in the next-gen programs and the safety and sustainability they will afford us. There is immense value in the collaborative work we do, and it is so important to that effort, and so important to that effort is the vision shared and cultivated by NASA. That, I would argue, has brought us a purity of purpose, the truth seekers, if you will, in the ATM world, and this has been a gift to the NASA and its stakeholders. And beyond visions, as I think is evidenced today in these statements and presentations, beyond the visions, NASA has been key to successful application of visions through trial efforts, such as the earliest manifestations in the future ATM concepts evaluation tools, IADS, as we're speaking to today, And today we continue to aspire through our digital information platform work with FAA and NASA, where we see the continued affirmation of the value of data science in our air transportation system. So these efforts go back, as many have noted, with Charlotte. Of course, Southwest Airlines only has 6 operations at Charlotte a day, but every flight matters in this system. And the integrity that ATD-2 has brought to our operation, beginning at Charlotte, is immensely important. We engaged in late 2018 and worked through Stormy 19, Stormy 20, and 2021 to see this effort through. For years, we have needed to implement sufficient air traffic management mechanisms to move away from what I refer to as the push for priority paradigm. That will help us overcome important limitations. We all have them: current automation, human to machine interface limitations. These will enable the balance needed through precision of response to the variability in an extremely dynamic environment, and to do so in a way that accounts much more effectively for the dynamic demand profile of the NAS, providing order and structure when it is needed most. Surface status remains one of the most challenging elements. These capabilities, paired with other emerging next-gen capabilities, will give the system and its stakeholders much greater sophistication in dealing with a progressively time and trajectory-based system of NAS management. This drives much greater fidelity into airline network execution and the NAS at large, greatly enhancing efficiency, reducing carbon emissions and block time variability, and ultimately serving the greater good of the traveling public. And with that, I thank you for the time for comment today, and I hand off to my colleague, Rich Santa, President, National Air Traffic Controllers Association. Thank you.
Thank you, Rick, and good afternoon. I am proud to begin my term working for the dedicated aviation safety professionals by representing NACA. I want to thank Administrator Dixon and Senator Nelson for their leadership, and all of my fellow participants here today for their partnership on this important modernization project. NACA remains committed to collaboration with the FAA, and ATD-2 is an excellent example of how our collaboration in the area of safety and technology has been very successful. The National Airspace System deserves the best tools to advance our shared mission of ensuring safety and efficiency. ATD-2 is operational right now and working at Charlotte and Dallas-Fort Worth airports. Controllers are using the technology in the day-to-day operations. And we're excited to have controllers at additional facilities involved in the current Phase 3. When ATD-2 becomes Terminal Flight Data Manager, it will help us solve traffic management problems within complex and busy terminal environments. Another benefit to controllers is that TFDM will replace the paper flight progress strips we've used for decades with electronic flight progress strips. It's a benefit anytime we can automate a manual process. We believe our collaboration with the FAA on ATD-2 has been critical to the current success, and we're proud of that. NACA is excited to be a collaborative partner in this important technology, but we must be able to maintain the system around it. Continued collaboration is vital for the development, the testing, and the deployment of TFDM, and we welcome working with the FAA to accomplish this modernization. I want to thank you again, and I will now introduce our next speakers, Akbar Salton and Sean England.
Muted, Akbar.
Thank you so much for that kind introduction. This capability is in a series of technologies that NASA has partnered with FAA as part of the next-gen ATM modernization for FAA's time-based flow management, traffic flow management system, as well as their terminal flight data management systems. The integrated arrival departure service management capability laid out for digital auto negotiation mentioned by Captain Goldman earlier between the airlines and FAA enables the most efficient operations to reduce delays, emissions, noise, and fuel. Senator Nelson also indicated an exciting set of technologies being developed by NASA for the future. We will further utilize flight planning through precision trajectory prediction and digital auto negotiation to deliver additional future capabilities. Moving forward, we look forward to partnering again with FAA, airlines, airports, and aviation systems manufacturers to deliver a series of exciting new technologies for reduced fuel, emissions, noise, and delays for the entire gate-to-gate flight domain, as well as efficient oceanic operations. Let me turn to my colleague here, Sean England, who will provide you all the additional details on the specific ATD-2 project. Sean?
Well, I don't know if we have all time for all the details, but I'll do my best. First, let me say that I'm thrilled to have this opportunity to share the great work of the ATD-2 team at NASA Ames and our field demo partners. It's just been a great collaboration. I'd like to use a little bit of my time to describe what was significant about ATD-2's field demo. We were a pathfinder for Terminal Flight Data Manager, which you've heard several times is the implementation program on the FAA side. And the thing about Terminal Flight Data Manager, or TFDM, is it requires an unprecedented degree of collaboration between air traffic control and the airline flight operators. Under TFDM, the FAA will be providing air traffic controllers with a new set of tools, and they'll be providing airlines with new data interfaces. However, the airlines will have to equip to interact with the TFDM system. So under the ATD-2 field demonstration, what we did within NASA was to develop both sides of that capability in a prototype sense and take it to the field to demonstrate that the TFDM concept would in fact work and deliver benefits in the real world environment. And this has been demonstrated. You've heard the mention of the benefits before. It's been a great success in partnership with our airline and airport partners. The key to the system that we demonstrated in Charlotte was this highly accurate surface predictive engine that could look at arrival traffic and departure constraints and the information from the airlines to push regarding the pushback plans and the predictions for when the flights will be leaving the gate, and put that all together in an integrated schedule whereby we could provide those benefits. So we built upon that highly accurate surface system that we demonstrated in Charlotte and extended it in North Texas in the partnership with Southwest Airlines and American and Dallas Love and DFW Airport to consider the elements of the problem that exist in the terminal environment. There's airspace constraints there that impact the surface situation. And so both the Charlotte demonstration and the North Texas demonstration were highly interrelated as we build on one from the next. And as has been mentioned, a lot of that work will continue under our sister project within NASA, the Air Traffic Management Explorations Project, as we move forward to that digital future. And with that, I'd like to now pass the mic over to my FAA colleagues, Steve Bradford from the NextGen organization and Wendy O'Connor from the Air Traffic Organization. Over to you, Steve and Wendy.
Good afternoon, and thank you for the opportunity to speak today, along with all my colleagues here and the people I've worked with in the past. So very much appreciated. As you've heard from previous speakers, NASA's airspace technology demonstration is proven capable of generating huge benefits for airports, airlines, and their passengers. But from the Air Traffic Organization, particularly Air Traffic Services, we've been working with industry and NASA on the development of the integrated arrival departure surface concept and technology to demonstrate benefits of a traffic management system for our complex terminal environments. In particular, as we spoke about many times, Charlotte and Fort Worth with our traffic controller workforce, in collaboration with our National Air Traffic Controller Association, have been working very closely with them. We do look forward in implementing the Terminal Flight Data Manager and continuing that testing and training and implementation, again, in collaboration with NACA, of course, and continue our partnership with industry on future ATD technology and next gen, of course. And so we just appreciate that collaboration and that partnership, and look forward to what more is to come from ATD. We've gotten several different developments from that research on the FAA side, and so we look forward to that as an air traffic controller organization. And with that, I'm going to introduce Steve Bradford, ATD-2 program lead for Next Gen, FAA Next Gen.
So I just want to talk a little bit about the process of tech transfer, because we've been talking about the tech transfer through this whole hour, and I just want to let you know that this is a very deliberate process that we take very seriously. We first discussed ATD-2 with NASA in 2015. By 2016, we had what we call a research transition team, and we had a joint management plan in which the FAA and NASA listed whose roles would be involved, what were the roles. We made sure that every aspect of the FAA that needed to be involved from the day one that's air traffic, that's the researchers, that's the acquirers in the program management office, flight standards where necessary. We listed out what the products would be. Would they be algorithms? Would they be human machine interface? Would they be draft requirements? Would they be draft procedures? And the nicest thing about the joint management plan and the collaboration with NASA is NASA has agreed early on that if a product that they were developing is part of our acquisition system, they would actually follow our format so that we could drop it into the acquisition and make it run more smoothly. Now, this process worked very well for ATD-2. It worked for ATD-1. It works so well that we're currently using it for urban air mobility /IAM. And Captain Goldman, don't worry, DIP is part of a joint management plan to come. And I'll stop there since we're running a little over.
Thank you very much. We are running over, but want to see if there's anyone who has questions for this panel of experts. Let's see. Okay, let's go to, I saw that Claudia with Air Traffic Management Magazine, she had her hand up earlier. Claudia?
Thank you, Jenny. Can you hear me okay?
Yes, we can hear you.
Great. So what I'd like to understand, you've touched on the technology transfer related to the ATM ATC function. Can you go into just a bit more detail as to how that takes place? Is this software? Is this new equipment that the controllers that will need to use? Can you talk about that a little bit?
Who wants to take that question from Claudia? Steve? You're on mute. Go ahead.
Yep, I'll take it. Yes, if it's software, if they've built a software product, they provide the software product as information which we can then provide to our vendors, whether it's the Leidos or Raytheon or whoever. So they provide software. If there's been a prototype of a CAI, human interface, they'll provide that. They typically do not provide automation, but they typically do use, where they can, they use the automation that we use. So if it needs to work with stars, they'll use a stars that they have. If it needs to work with ERAM, it'll work with an ERAM copy they have, and they'll be prototypes. Those prototypes, clearly the ATD-2 software and the procedures, etc., will be passed off the TFDM office and will be implemented by the TFDM vendor. So it's a little bit of both. It's never a huge automation system being transferred, but it's all the intellectual property, algorithms, procedures, etc., that will be transferred over.
Okay, great. So then the vendors will be responsible for integrating the functionality, and then it doesn't require actually changing out the equipment. It's more of a software upgrade, correct?
Or it'll be new equipment like TFDM, where they'll be responsible for integrating it into the new equipment.
Okay, great. Thank you.
Thank you. Let's go to Robert Silk with Travel Weekly. Robert? Who's your question for?
I'm not sure who would want to take it, but it's a
pretty straightforward one, which is, it's a two-part. First of all, how long will it likely be before we'll see this ATD-2 in use at all 27 of these airports? And will it be used by all airlines at all these airports? Or not
Pam?
used, will they be involved with it?
Pam, do you want to take that?
I think maybe Wendy and I should take that.
Okay.
That's fine.
We're rolling it out to Phoenix and then to Charlotte. Been a little bit of a delay with COVID, but it starts there. Do you remember the end of the waterfall for this part? I think it's 10 years before we get to all the facilities.
Approximately 10 years. That's correct, Steve. And hopefully we'll roll it out to Phoenix by early part of next year.
Right. And then once it's in Phoenix, they can use it. It's always voluntary, but then you suffer old methods if you don't participate. But all the airlines are participating. And as part of ATD-2, we actually demonstrated a capability where non-airline participants could participate through mobile devices. And so we don't think that participation is a huge barrier.
Okay, thank you.
Okay, let's go to Oriana with Politico. Can somebody unmute Oriana, please?
Hello, can you hear me?
Yes, we can hear you. Thank you. Oriana, you're muted again.
Okay, I'm sorry.
No worries.
Okay. My question is for Steve Bradford. I know that the FAA is making plans for significant restructuring that, among other changes, would move or create new positions in the agency's air traffic control office. And I know that would be within the air traffic organization, program management organization. So, Next Gen obviously would see some shifting there. And I'm curious if the proposed restructuring would affect how ATD-2 is implemented in any way going forward at these 27 airports. Thanks.
So I don't want to comment on the reorganization. That's Mr. Dixon's.
Yeah, so Oriana, we'll
But
take
let me take the second half of it, which is, I think, is
Yeah.
a real question. There is nothing about a reorganization that would affect the rollout of ATD-2 TFDM, because that is currently within the ATO. It's within the program management office. It's delivering the tools, and it's with Wendy's group for the integration of the operations. So nothing about the reorganization would have, if we do it, would have any effect on ATD-2.
Right, and it would be using our existing air traffic controller workforce, not necessarily adding positions.
There's nothing in the reorganization, and I'll speak for Steve on this one. There's nothing in the reorganization that's been proposed that adds any positions. It's just a shifting of alignment of organizations.
Okay, thank you. All right, let's go to Micah, please. The Wall Street Journal.
Yes. Hello. Can you guys hear me?
Yes, we can.
Okay, great. So I just wanted to follow up on the press release says that in Charlotte over 4 years, 916 hours of reduced delays, right, were achieved. If you do the math there, that games out to about 38 minutes of reduced delays a day. I don't know who would take this question, maybe from the FAA side, but do you believe that you can achieve at least that level of delays at the 27 other airports where you're rolling out? Or is there something in terms of like how much delay reduction you can achieve at each airport is dependent on specific factors to each facility? Thank you.
I'm going to turn to Pam for that answer, Micah. Pam?
Okay, thanks for turning to me. I'm not sure why you turned to me. Probably Steve would have been better. I think it is very airport specific. So no two airports have the same amount of traffic. The configurations are different. What we do know is that the technology will allow us to share information between our air traffic control facility and the airline. So the concepts in terms of the pre-flight exchange, the pre-flight planning, and the ability to provide that picture will be available. What you get at each airport is very specific to the configuration and the situation at that airport.
Okay, thank you. Yes, Sean.
Yeah, I was just going to add a little technical thing. Pam's exactly right. It's very, very airport specific. The technical aspect on the benefits mechanism is the surface metering doesn't change the delay. It just shifts some of the wait time from the end of the runway to the gate, but that's very important from the environmental savings point of view. The delay savings actually accrue when you're that insertion into the overhead stream and the opportunity to look for earlier slots in the overhead stream, given the better surface prediction capabilities of ATD-2 and TFDM in the future. Steve and Wendy, did you want to add anything to that?
No, thank you. I agree with you and Pam, definitely. Thank you.
I think Rob wanted to say something though.
Yeah, and it sort of ties into an earlier question that Steve, you had answered. Will the airlines participate? And it's unequivocally yes. Of course, we're all looking for reduction in fuel and reduction in emissions. So we all want to contribute. What it really amounts to is sharing data, and we've spoken about that before. We're already doing that. We're already providing readiness information. We're working on providing it that's more accurate, but we're pretty much there. The key is in the technology and the tools that the FAA is deploying, with TFDM, that will take that data. We'll make the calculations and they'll allow the controllers to act upon it. So I think it ties into both this question and the earlier question about the participation.
Thank you, Captain Goldman. And we have run out of time, so we need to wrap this up. I want to thank everyone for being here today for a great program, great news today. So thanks to everyone for joining us, and everyone have a great afternoon.